Hi Yates, this is lesson 4, looking at thermosetting polymers this time. Now just to recap on last week where we looked at thermoforming, alright, it is important that you remember the difference. So remember thermoforming, if you look at the little spaghetti-like diagram here, the molecules do not create a tight enough bond for them to become completely and utterly bonded together. Okay, so they're much weaker, and that means that they're allowed to, they can reshape when they're reheated. So remember the difference is thermoforming polymers can be reheated several times over in order to create different shapes, change it, whereas today's thermosetting polymers are not able to do that. Okay, the main difference is thermoforming can be reshaped and they can be recycled, and you know, in this modern age that is a very important point to remember. Thermoforming polymers can be recycled. So today we're going to look at thermosetting and see what the differences are, and look at 4 or so different versions. So thermosetting polymers, the definition is unable to be reformed after the first reshaping. Okay, so instead of the way thermoforming polymers work, they can only be shaped once. All right, they can't be changed once you've done it. That is it. It's set, and that's the key word, is set there. All right. Now the problem with that obviously is once they're set, you can't remold it if you made a mistake or it's not quite the right shape or size. It has to be redone again. All right. The molecules in this have such a strong bond that they cannot be pulled apart. All right, and because of that, they can't be reshaped, and importantly as well, they cannot be recycled. So you can't put this in your recycling bin and then they go off being mushed down and chipped up and remelted into something else. That's it. It's done. All right. So environmentally, it's one of those issues that we have to think about, whether, you know, environmentally we want to use these. So they are used predominantly for things like electrical casings and plugs, because of the fact that they cannot be melted down. That's a safety issue. All right, it's not an aesthetic issue or, you know, something that you want it to look pretty. That is what it's for. All right. So the first thermosetting polymer we're going to look at, for most of us, we wouldn't think of it as a plastic or something that makes an item, or, you know, something that we would hold or use. We know epoxy resin basically as a glue. Okay, it comes in 2 tubes. You mix the 2 together, has a chemical reaction, and then becomes very sticky, and when glued together, very hard glue. Okay, it's got what's called good chemical resistance. Okay, and wear resistance, which means, you know, it can take a lot of, if you drop any chemicals on it, it's not going to melt. Some polymers, if you drop something on it like that's got a chemical base to it, or sort of like a thinning liquid in it, it will start to melt. Okay, this won't. Right, so it's a very strong bond. Right, and it's used for, as we would use it, for glue. You might know a term called araldite. That's the actual sort of product name of it, but it's called epoxy resin. Now the next one, melamine formaldehyde. Okay, now again, you will probably have used this, and it's ideal for things like tableware. So if you're at a barbecue or something like that, or out on a picnic, if you don't want to be using ceramic, which if you drop it outside might break, a lot of the time you'll see this kind of item at sort of picnics and barbecues and outdoor facilities, or children's utensils will be made out of it because it's very strong and hard. Okay, it's also used for things like kitchen surfaces. Again, strong, hard, and resistant to heat. So if you put your pan on it, the likelihood is you're not going to get a mark on it. It's not going to, well, it's not going to remelt, and it's certainly not going to, you know, sort of mush away under the heat from the pan. You might get a little bit of mark from it, but it's not going to completely disintegrate. Okay, so that you'll see in kitchens, for kitchen worktops, instead of things like natural timbers or granite. that is a very popular choice to use. Polyester resin. Now again, that is something which is brittle. Brittle means if it breaks quite easily, which sounds, well, what's the point of that? However, if you use it with glass fibre, and it's glued onto with the glass fibre, it becomes extremely tough, and it's very nice to use for moulding. So you can see here, you can mould the shape of this. It's got a lot of different angles to it, and it's very specifically shaped. Okay, so you can make things of a very tight, specific shape by having this thin, brittle polyester resin, but then you can reinforce it with the what's called GRP, glass reinforced plastic, and it will make, with the laminated glass, it will make it a lot stronger. And it's very, very lightweight. So for things like bolts and car body panels, it's ideal. If you want to be going fast, you want it to be light. So it's perfect for that. All right. Now the final one, urea formaldehyde, is something that you will have seen and touched all around the house. Okay. It says it's a good electrical insulator, so it's not going to melt. It's not going to change under heat, and if your plug sockets, they get a lot of electricity through. You don't want them to be disintegrating, so it's ideal for things which are called white electrical fittings. So your plug sockets, your plugs, they'll all have this particular material as their base. Toilet seats, and again some glues. Now if you use an MDF, you would have the glue that glues all the different little layers together, would be this particular product as well. So it's used not just as a solid, so you can see it and you can touch it, but it's also used in a similar way to epoxy resin as an adhesive, a glue. Okay. So finally, your fact test. So there's not an awful lot to do this week, but it's important that you remember these things. Okay, so I haven't given you a lot to do, but over the next week I want you to really be looking at the polymer fact test today and the one of last week, so that you really do understand the differences between thermoforming and thermosetting, and the names of them and the properties. Okay, so remember, when we talk about property, we mean what it is, what's good about it. Okay, so when we talk about epoxy resin, for instance, we'd say it's a good insulator, it's got good chemical wear, and then we talk about a use, which would be such as a glue, an adhesive. All right, so you need to be able to recognise and understand the differences between the two. Okay, and the reason why I'm not giving you an awful lot is because they do have long words. The thermoforming ones, there's a lot to remember, and I want you to make sure that those are the facts that you really do remember. Doesn't seem like a lot, but it is complicated to remember which one goes with which and what property is used, etc., etc. So I want you to really work hard in order to get that knowledge in. Okay, so that's why it's quite short this week, and that's why there isn't a great deal, but it's important that you do know the differences between the two, and you're able to identify a property and a use for each one. Okay, so today's, again, is just like last week, filling in the gaps and making sure that you get the right words. Now, like I said last week, don't get bogged down by how many dashes there are. Okay, that's not important. Don't count them because it might not match up. Just fill them in, and then I'd like you to try and sort of do maybe a little revision exercise, looking at what we've looked at so far, lessons 1, 2, 3, and 4, as there will be a quiz test in the future on these. Okay, so it's important that you do a little bit of revision this week as well. Okay, I'll see you next time. Thank you.